Hi, my name is Yukiko, and this is my research about ballet-based movement as a supportive strategy for motor function in amyotrophic lateral sclerosis, also known as ALS. ALS is a rapidly developing neurodegenerative disease with no curative treatment, causing severe motor impairment and significant gaps in rehabilitation options. It is characterized by the degeneration of upper and lower motor neurons, resulting in muscle weakness and eventually paralysis. An issue is that despite the availability of disease-modifying agents such as riluzole and edarvin, no current treatment is able to stop or reverse neurodegeneration. This demonstrates a significant gap in treatment and highlights the need for complementary therapeutic models beyond pharmacological intervention. In a research of repeated movement in imagery, the hypothesis is that in a healthy adult, simple low-intensity ballet movement would trigger measurable changes in brain activity reflected as increase in chill scores, which is a composite index to quantify states of relaxed alertness, focus, and reduced cognitive stress. The results show that as the number of trials increased, baseline brain activity measured by chill score decreased across both sections. However, repeated trials continued to produce strong immediate neuroresponses. Active movement in particular showed more sustained effects with elevated chill score lasting longer than imagery. Further, brief low-intensity ballet movement produced a strong acute effect on brain activity with immediate increase in regulated attentional engagement followed by partial decay over time. Importantly, the use of low-intensity movement is critical because in the context of ALS, excessive muscular strain can contribute to fatigue and overwork weakness, so maintaining gentle control movement allows for neural engagement without placing additional stress on the body. This suggests that structured, low-impact ballet sequence can serve as a practical and non-invasive way to actively stimulate both motor and cognitive systems while remaining safe and accessible for potential clinical use. In the context of ALS, where current treatment are limited and often rely heavily on medication, this provides an alternative strategy that supports neural activity without placing additional strain on the body. While motor imagery also produced measurable changes in the brain activity, these effects were shorter-lived. This indicates that imagery may be particularly useful in later stages of ALS where physical movement is limited, serving as a complementary approach for active movement. Overall, these findings suggest that integration of low-intensity movement-based therapies alongside existing treatment expands the range of non-invasive options that can become available for individuals with neurodegenerative diseases. This reflects a broader shift in treatment, one that not only addresses disease through medication, but also fosters the body's natural capacity for regulation and adaptation through structured movement. If validated in clinical population, this model could form a foundation for integrating low-intensity rhythmic movement into ALS rehabilitation. Thank you for listening.